All right. Christophe?
All right. Well, thank you. Yep. Thank you, Alan. Can you hear me okay? I'm assuming that that's a yes. Good afternoon, everybody. Once again, my name is Christophe Coenraets. I'm a technical evangelist with Adobe. And as Alan mentioned, today I will speak about architecting a PhoneGap application. You can see a lot of the content that I will be covering today on my blog. I've been blogging a lot about that in recent months. And from there, you will also find links to GitHub and a lot of the examples that I will cover today. You can find the code on GitHub, and there is, of course, some new code as well. So what I'm going to do, I have a few slides, and I'm going to switch back and forth between slides and code. And at the end of the presentation, I will leave some time for Q&A. You'll have the opportunity to ask questions in the Q&A panel in the web conferencing system, in the Connect panel there. So with that, let's get started. And I'm going to level set a little bit as a starting point here. So I'm assuming that most of you know what PhoneGap is about, so we'll not really talk about that too much. If you have never heard anything about PhoneGap, essentially PhoneGap is a way to avoid what you see on this screen, which is that you would have to build a native application for each mobile platform that you target. So with PhoneGap, we use the web standards, if you want, as an abstraction layer. So you're going to be able to build your application with HTML, JavaScript, and CSS, and deploy that same code base on all these different platforms. And essentially, that's what we call a hybrid application. A hybrid application is essentially a native application that renders most of its content using HTML. But it's important for the rest of the presentation to understand that we are dealing, in fact, with a native application, and that's kind of that red shell that you see around the HTML on each platform. That's the native part, and that's kind of the PhoneGap wrapper and the PhoneGap bridge that's provided to you as a native application. And why is it important to have that wrapper? So that you can deploy your application on the different app stores, because obviously Apple wouldn't take a bunch of HTML files to the App Store. What you need to submit is indeed a native application, and the PhoneGap is going to essentially wrap your web application as a native app for each platform. So that's in a nutshell reviewing what we're going to talk about today. Now, when I speak about hybrid applications or PhoneGap applications versus native, it's important to understand the differences, and again, that's going to be very important for the architecture discussion that we will have in a minute. Essentially, there are bunch of differences, but the most important ones are, first of all, the language that you're going to use to build the application. If you build a PhoneGap application, you basically leverage your web skills. You use JavaScript as the language, as opposed to using a bunch of native languages, if you want. A hybrid application is going to be cross-platform. Both will be deployed through the different app stores. There is a slight benefit in using hybrid application on the next line, and that is that you can actually update parts of the application without resubmitting a new version of your application to the App Store. Because if you think about it, a PhoneGap application is just a collection of HTML, JavaScript, and CSS. So you could actually change some HTML on a server and transparently kind of change at least a part of the application, and we'll speak about that a little bit today as well. If you use a native application, obviously, if you want to make an update, you basically have to submit a new version of the application to the App Store. There are some different APIs that you use for graphics, but the next one on the list here is really a lot of what we will be talking about today. A lot of people out there, that's probably the first question that people ask is, what about performance? Is a hybrid application as fast as a native application? Is it fast enough? And we'll talk a lot about that. That's going to be a big part of the architectural discussion that we will have. Now, let me just introduce the topic a little bit by saying that obviously, and I'm sure you all understand that, a native application is always going to be faster than a web application for some obvious reasons. You run native code versus a code that has to be interpreted inside the browser. Now, the real question is, does it matter? Are you going to see the difference? And a lot of that depends on the type of application that you build. I will argue here that for many, many applications, you're not even going to see the difference, assuming that you architect it right, hence the topic of today. But obviously, for some applications, you are going to see the difference if you build a kind of a wild, crazy 3D game. You're going to see the difference. If you build a crazy trader desktop, if you're in New York building trader desktop applications, and you need to stream 2,000 stock updates per second in some kind of a grid, then maybe you're going to see a difference there. So there are certainly use cases, situations where a native is going to be something to consider, but again, for many applications, the hybrid is going to be the hybrid model is going to be fast enough. So that's kind of to set the stage a little bit, and with that we can really start the discussion of today, which is, okay, we have all seen these Hello World applications, and I've been guilty of presenting some maybe to some of you, and that makes sense. You need to start somewhere, but after Hello World, sometimes we leave you a little bit in the dark, and that's how problems happen, because then people say, okay, well, I built that application, but it's not performing well, or my code is not very manageable. And the goal of this presentation is really to provide guidance in terms of how you go about architecting a PhoneGap application that is not a trivial application. So let's establish some core goals for the type of architecture that we will be talking about. What we want is performance, 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 and that means that we essentially want a native-like user experience. But as part of that, we also want to be able to manage the code, over time, and also manage the code in a, among a group of developer. And so when we think about architecture, that's going to be an important point as well. And we also want to write code that can be tested, and that's obviously somehow related to the performance topic. Important way to be able to build for performance is to be able to test your code and make sure that it performs well. So these are some of the core goals that we will be talking about today. So what I'm going to do is actually take you through a very simple application but it's simple enough so that we can all understand it because we only have an hour. However, it's basically a kind of a starting point. It's a good framework. It's an application that can be complex enough so that most of the problems that you would typically encounter when building an application will actually show up in this application. So the rest of the presentation is going to be a kind of a set of principles that we kind of came up with, and I came up with, and other developers came up with as we were building these applications, and as we went through, the experience of building a decent number of these applications. They are not necessarily in a logical order, except that when I take you through the application, we will start with this one. So the first one that I think is actually important, the first principle, is to abstract your data access logic. In other words, by that I mean that when you start building the client side of the application, you shouldn't really care about the real way you will get to your data. And that is for a number of reasons. First of all, that layer of services, back-end services may not be ready. It may change. It will, if you embed data access logic as a kind of a hard-coded thing in your application and you rely on a server, it's going to make it difficult to test your application. So by abstracting the data access logic, I mean that it's a good idea to implement some pluggability layer here. In other words, if I start building the application, maybe I will work with some local data in memory, and I will create a data store object that will just work with sample data in memory. Or I can unplug that object and plug another data access object that will do the same thing but with a local shared object or a local database. And then I will create a third object that will indeed go to the server to get the data from the server. Now the key thing is to provide, to create these objects with a consistent interface so that the impact on the rest of the application is very limited. But as I mentioned before, there are many benefits to that. The first one is what I call experience first, which means that you can really focus on what you want the experience to be, as opposed to build an application that's really driven by the data services that you get from a server. So you can kind of forget the structure of the data for a second and really focus on, okay, if I didn't have to care about the data, this is really the user experience that I would like to deliver. And you can iterate very fast through these prototypes to really focus on the user experience. Another benefit is also that if you have some dummy data store objects that you can plug in to your application, obviously it's going to be a lot easier to test, and specifically to do unit testing that will be very isolated and that will not rely on many additional layers, including server layers. So let me take a break from my slides here and show you a typical example of the way you could do that. And of course, this is very kind of simplified at this point in this application, but we'll keep building on top of this. So I have a simple application. Maybe I will show you how it works here. It's very, very simple at this point. So I just have a search box here, and in that search box, I can type a few letters, and it's gonna filter some data. It's gonna retrieve some data. We will build the employee directory that I always use as an example to kind of tackle the different problems that you face when building an application. So get the idea. Very simple at this point. We'll make it a lot more interesting in a second, but let's look at the code so far. So you see that I have a very basic HTML structure here and a few libraries. But what's really interesting is that you have different data store objects, and that's what I was talking about before. Like, for instance, you have one that I called memory store. And a memory store, basically you see the interface, the API, if you want, that's defined here. You should be able to look for employees by name, by ID. And because it's a memory store, you see that, I have a kind of dummy data here, but yet, everything works as expected, simply calling that standardized API. Now, one thing that I did here is to actually simulate in my standard API, I actually simulate asynchronous calls so that it will work fine with, again, the same consistent API when I will introduce a data store that will actually go get data from a server, because, of course, that's going to be asynchronous. And if I want, all the objects to behave the same way, in my simple memory store here, I fake, kind of an asynchronous call using a set timeout here. So that's a memory store. Similarly, I have a web SQL store. So if you wanted to, save data locally so that you can work with the application offline, you notice that I have an object to do that as well. But what's really interesting is that it provides the exact same API, including find by name, find by ID, etc. And then I have a third implementation of the same storage object, find by name, find by ID, and things like that. So I think you get the idea. Now, in my main application, you see that I was actually using the memory store, and I could very easily change here to my web SQL store, for instance, and the application should still be running fine, but now I have a completely different data access logic. And when you'll finally be ready to provide, the data from the server, you just add, an additional data store that you can then plug into the application. But by doing this with, starting with a simple memory store object, I don't have to worry too much about the data. This is easy to change, and I get the user experience right, and then, I can focus on my data access layer. So this is a little different and maybe controversial for some of you, and including me, where typically we, like 10 years ago, we always started with what we considered the foundation of the application, which was, the back end and the services. In this case, this is a kind of another metaphor. That's what we call experience first here. Get the experience right, and then worry about real data integration, because let's face it, these mobile applications are a lot about experience. Okay, so with that covered, let's speak about a second principle that we always try to implement when we build a mobile application with PhoneGap. That principle is about making sure that you can always run your application in your browser on your development machine. Now that may seem obvious because, again, a PhoneGap application is just HTML and JavaScript, but it's easy to get carried away and to start using, PhoneGap, kind of bridging APIs that would actually break the ability to run your app inside the browser. And that's a big problem for a couple of reasons. In that case, you would basically have to, every time you want to test, you just change a comma. If you want to test your application again, you need to create a build, a native build, the wrapper, and that's not always obvious. Then, install the new version on your device and test it on your device. So as much as you can, make sure that you do whatever is needed so that your application will run in the browser. Now, you don't want to compromise the native behavior. So in other words, even though your application has to run in the browser, when it runs on the device, you actually want the closest to native experience that you can get. So the way to do that, the way to kind of implement that principle, there are different approaches. The simple one is to simply guard your code. By that I mean, okay, in your JavaScript you would say something like, well, if I'm somehow running on my device, or if the GPS is available, then do this, else do that, as opposed to just assuming that the GPS is available and that then your application would break if it was not available. So that's kind of the cheap way of doing it. The most kind of object-oriented way of doing it is, again, to use a common interface with pluggable objects. So you would have a pluggable object that would be instantiated if you run inside a browser, and then another object implementing the same interface that would be implemented if the GPS was available or if you were running on your device. So why is it so important? As many of you know, one thing that is extremely hard to do, and we'll speak more about that when building mobile applications, is the debugging part. And by debugging, I mean profiling, inspecting the DOM, and things like that. And that's, even though we made progress there, and there are some, solutions, it is a lot, and I really mean a lot, easier to debug your application inside Chrome, for instance. So if you break that ability to run inside Chrome, then you give up on these debugging options, and now you have to deal with the hard way of doing it. So this is why it is so important. And you need to be very picky and very perfectionist here, because it's easy to forget to do things like that. And let me give you an example. I'll go back to I'll go back to my code here, and a simple, the simple example that I will use here is the idea of displaying alerts to the user. Something went wrong, or it's simply warning or something like that. So this is the lazy way, or kind of the cheap way that people do it in JavaScript, right? You want to display an alert, and you use the JavaScript alert. Okay, so let's test that and see what we get. Okay, so of course in this case it's not really needed, but I wanted to display an alert and say, okay, the data store has been initialized. Imagine seeing this type of message on your device, and that's exactly what you would see. You would see something like this, localhost says, stored initialized. That immediately gives away the fact that your application is not native and that you're actually running inside a web view, because this is clearly a JavaScript alert. Now, the way to have the best of both worlds is to do this, is to test if you have an object navigator that has the notification property, which would mean in that case that PhoneGap has been initialized and that the notification object is available on your platform. Then you're going to use navigator.notification.alert, and PhoneGap is going to bridge that to a native pop-up dialog, and so your application will indeed look native. Now, if you simply always do this, then you fall into the problem that I mentioned below, is that it's going to run just fine on your device, but all of a sudden your application doesn't run, or at least doesn't run correctly inside a browser anymore, because obviously a browser doesn't know, if you run it in Chrome, it doesn't have that alert method on the notification object, and then it doesn't work. Again, this is a cheap way of doing it. You can improve that by implementing pluggable objects and things like that, but you get the idea. Okay, so let me go back to my slides here, and we'll move on to really the core of the discussion here. So this is a traditional web app, and this is the representation of a traditional web app, and you have all seen this, and maybe you have all built this. This is the well-known sitemap, if you want, where you look at a web app, and basically it's a bunch of pages, and each box on this slide essentially represents, a piece of the UI, a page, and that page has been, the UI of that page has been generated at the server side using some kind of server-side scripting. It may be, Java and JSPs or servlets. It may be ASP, PHP, Ruby on Rails, Node.js. It doesn't matter. The point is, in the traditional way of building a web app, that's really what happens. You go to the server to get a page. There is a server-side script that runs, generates a page, and gives you that page. And because we often say, okay, a PhoneGap application is essentially a web app, sometimes people assume that they are still going to do it this way. And of course, you could do it this way, but I will give you the hint already that your application is not going to perform well, and the experience is certainly not going to be good. So this is the old way of building a web app, and typically you still use that approach when you build a traditional website. Now, this is a new way of building a web app, and it's essentially, this is essentially the only HTML page that you would have, as part of your application. It's essentially an empty page, and you are gonna dynamically, using JavaScript, you're going to build the UI as needed. As the user navigates through your app, you're going to use JavaScript to instantiate DOM elements, inject these elements into the DOM, and then remove them when the user moves on to something else. But the entire application lives into the same page, and you simply inject and then remove elements into that page as needed. So the metaphor, if you want here, is a lot closer to building a traditional application, in Java, client application in Java, in C#, in C++, Visual Basic, or whatever. It's really an application metaphor, a lot more than the traditional page metaphor that you've been using when building traditional websites. Now, this is obviously completely different compared to the previous approach, and I wanted to take a second to really compare the two approaches here. So the last one that I discussed is known as a single-page application or single-page architecture, and the previous one was, the traditional multi-page application. In the single-page architecture, as I said, you use JavaScript to build a UI dynamically. With the multi-page architecture, the server generates the UI, and it leads to many pages being served as a succession of pages to the client, whereas in a single-page application, as I mentioned before, you only have one page. The UI is generated at the client side in a single-page application. It's generated at the server side in the traditional approach. Now, that is going to be extremely important. Why? Because if you build a mobile application, most people will expect that mobile application to work offline. So right there, if you rely on a server to generate the UI, obviously your application is not going to work offline, and so this architecture would be out already. Whereas in a single-page architecture, you do everything at the client side. You use JavaScript to do that. At the server side, you would use some scripting language. I mentioned that before. We spoke about offline. Another extremely important point of difference between these two architectures is that if you do the multi-page architecture, you as the developer, you do not have full control over the user experience. Why? Because the browser is going to be responsible for transitioning from one page to the other page. And how does the browser do that? It basically, gets rid of one page and just displays the next page with no transition whatsoever. So it's your traditional browser moving from one page to the other page. Now, that sounds good in traditional websites, but in mobile applications, people want a nicer experience. Maybe they want a page to, to slide, the old page to slide to the left, and the new page to slide from the right. If you use a multi-page architecture, you can't really control that experience. You leave it to the browser, and that obviously limits the quality of the user experience. Another problem, if you were to build a PhoneGap application using the multi-page architecture, is that a lot of your application assets, and that includes JavaScript libraries and maybe style sheets and things like that, would be loaded again and again. With every single page, you would have to reload your JavaScript libraries. You would have to reload your style sheets. Obviously, some of that can be cached, but still you will pay a price for that. It's not going to be, completely transparent. If you have a single page architecture, you load these assets, your JavaScript libraries, style sheets, only once, and it's there in memory because you never leave that specific DOM. So that's going to lead to very laggy very laggy user experience if you use a multi-page architecture, and a pretty responsive experience if you use a single-page architecture. So let me quickly show you something here. I'm going to try to show you two different versions of the same application on my phone. It's going to just take a second to get set up here. All right. Okay, so what I'm showing you here is essentially the multi-page architecture, where essentially at the client side you have an empty index.html, and the only thing it's going to do, it's going to bootstrap your application that runs on the server, and of course you don't have to have that link. You can do that automatically. So the index.html that runs locally on your phone, the only thing it does is to really load the application running on the server. And now I'm going to try to give you an idea of the user experience here. Now, over the web conference, it's not going to be obvious, but hopefully you will see, a delay between the time. See, when I highlight a list item here, there is about 2 seconds before it really responds to it. So that's the first thing. It's lagging. Why? Because the UI is being generated at the server side, and my internet connection here is pretty good. If I was in the wild, it would be a lot worse. And the other thing that you notice is that there is no way I can have nice page transitions here. This is really the browser in charge of replacing one page by another page. Now let me show you an implementation here with the single page architecture. It's a little more sophisticated actually. And you see here, you notice a few things. So first of all, I don't know if you can see the difference through the web conference here, but it's a lot more responsive. And also, I have full control over the transitions. In my application, I can do exactly what I want. In this case, I'm using sliding, but it's totally up to you to do whatever you want. So that's kind of an example of the difference between the two architectures. Now, I need to mention one thing. There is actually a kind of a third option here, which I call the page injection architecture, that solves some of the problem of the multi-page architecture, but not all of them. And the reason I added that column is because that's essentially the architecture that jQuery Mobile is using by default. It's kind of the way they thought about building the framework. And a lot of people start PhoneGap with jQuery Mobile, and the performance that they get is not always good. and let me explain why here. So the difference here is that the pages are still created. As you can see, UI generation tier, the pages are still generated at the server side using PHP or JSP or ASP. But jQuery Mobile would actually request the pages using an AJAX request. And the only reason they do that is that they get the page from the server and then they inject that page into a single DOM. So in a way, it's a real single page application, but the pages are still generated at the server side and then injected into the DOM. Now, it's still laggy. Why is it still laggy? Because you're still relying on the server to actually generate the pages, and it still has the problems of not working offline. Now, you can work around that in jQuery Mobile, but that's really how they architected the framework. That was the approach that they had in mind, because initially, actually, jQuery Mobile was not built for apps a la PhoneGap, but it was built for mobile websites. So there was still a server there that they wanted to leverage. So I wanted to make it clear that when you use jQuery Mobile that way, the default way, you are not really getting the best user experience, because you are still relying on the server to generate the UI, and depending on the latency of your connection, you're going to run into some performance problems as well. Okay, so that leads us to the conclusion of this part. Use single page architecture, rely on that architecture as much as you can. Sometimes you can use a combination of different architectures, but really try to rely on the single page architecture as much as you can. Why? Because it's going to give you a much more responsive user experience. Everything is created at the client side. You don't wait for a server. It can work offline. You have full control of the user experience. You can slide between pages and things like that. So altogether, it's going to give you a much more responsive type of experience. Now, it does lead to a problem though, because that's kind of how your code will essentially start to look like if you implement a single page architecture. You're basically, as I mentioned before, you're basically using JavaScript to compose HTML. And so you end up with stuff like that, and I don't ask you to understand exactly what's happening here, but what you see is that you have a lot of HTML embedded in JavaScript, because I'm basically creating a view fragment in JavaScript. Needless to say that this code is extremely difficult, well, to write initially, but most importantly to maintain, because you can't really leverage the HTML capabilities of your editor, because all that HTML is embedded into code. It's hard to read, hard to maintain. So there is a way around that, and the way around that is to actually use HTML templates. And with HTML templates, you write HTML the way you always write HTML, but as you can see, you can then define placeholders, like for instance, you see that H3 there with first name and last name. So different template engines will use a different syntax for the placeholders, but it's really a lot cleaner to do it this way. So you have you have different templates, a lot more easy to write. You can still use the HTML capabilities of your code editor, and a lot easier to maintain. So that leads us to really the fourth principle here, which is to use templates as much as you can. And a lot of these template engines will let you compile templates, which essentially means that it's going to create a function, a kind of a precompiled function with the substitution logic baked in, so that when you really have to merge data into a template, it's going to be a lot faster. Now, I'm not going to recommend a specific template engine, but there are different options. There is mustache.js, handlebar.js. For people using Backbone, Backbone is built on top of Underscore, which has some simple template capabilities, and there are other ones that are available too. Do some research in terms of performance. They don't all perform the same way, so performance is obviously key, and see what works for you. So let me switch back to the code for a second and try to catch up with what we did before. I'm going to show you something that is really painful to watch, pretty ugly to watch. And that was the multi-page architecture, the PhoneGap version of the application that I showed you on my phone. And you see that in this case, the HTML is built really the old way. In this case, it's PHP, but it could be Node, it could be JSP or ASP. You see the HTML with embedded PHP code. That's really what I want you to try to avoid. And instead of that, use the single-page architecture approach. So let me show you how that works at a basic level. Remember, until now, our very simple UI looked like this. This was index.html, and I had some baked-in HTML elements. So how do you go about implementing a single-page architecture? You basically, if I look at my index.html now, there is really nothing in terms of HTML markup. But in this very simple implementation, in my main JavaScript file, I will have a function here. And you see that what I'm doing, I'm basically building some HTML in JavaScript, right? And then I store that in a variable, and then I assign that HTML that I built to the body. And then if you need to show another page, you get it. What we'll do is we'll create some other HTML, and we'll assign that to the body or to a more specific part of the page. So, but that's kind of the hard way of doing it. That's where we have a lot of HTML kind of hard-coded in the middle of JavaScript. So let's see how we can solve that problem with templates. So in my index.html, I can define templates. So here is a template for the home page. You notice that an easy way to build a template is to actually define it into a script tag with a type text template or something like that, and then you write your template this way. And so that's for the home page, and then I created a second template here to display the list of employees, and you see that here I do some substitutions with these placeholders. This is using handlebar.js. All right, so that's how it works. Now, let me, as I'm here, mention that this is fine for a small demo to define all your templates inside index.html. It's not going to be very practical and manageable for a large application. So I recommend, if you build a non-trivial application, to externalize these templates into their own HTML file and use some kind of a template loading technique. I have a few template loaders on my blog, or you can use require.js and load text modules using require.js to kind of if you build a large application, you're going to have dozens of these templates, and just keeping them all in index.html is just not going to be practical. Okay, so now that we have defined the templates, let's go back to the main JavaScript file here, and you see that using handlebar, I can actually compile my templates, okay, and then to actually display data, I can then invoke the function that is created by compiling a template. So compiling a template gives you a function that for instance, in my render home view, I can invoke that function. In this case, I don't have any data to merge, but in other situations, like for instance here, to display the list of employees. So this is the function that was created by compiling the list template, and now I'm going to pass an array of objects, and it's going to take care of merging everything, and that's basically how it looks. And you see that all of a sudden this code is a lot cleaner because you don't have any embedded HTML anymore. We're good with that. All right, so the code so far is okay, but there are still a lot of issues. Remember, I have a function in my main application object that's called render home view, and then you can imagine I'll have to add another function that's called, render, maybe employee details view, render employee direct reports view. At some point, it's going to be out of control, that main application object with all these render this, render that functions. That's not going to be practical. That's not going to be, manageable. It's not very OO if you want to just stuff all these methods in a single object. So what you really want to do is use, the patterns that you know from other languages or from the server side, is to actually partition your application into different types of objects. View objects, model objects, controller objects, or model view. So there are different kind of subtleties here between an MVC architecture, MVVM architecture, and this is beyond the scope of this presentation. You choose one. The important thing is to really partition your application. It's gonna make your code a lot more manageable, testable, and reusable. So let me show you a very simple implementation of this here. So remember, the situation so far is that, in fact, we see it here. I have that render home view logic that is basically part of the application object, not very reusable. So what I'm going to do here is simply create a home view object. So that's a JavaScript object that has a few methods. Initialize the view, render the view, that's going to do what it says it does, and then maybe a few additional methods. And by the way, all the template logic for that view is part of it as well. So now everything is really encapsulated. And when I call my when I look at my main JavaScript file, you see that it becomes a lot cleaner. The only thing I do here now is to actually instantiate that view. So that's kind of a baby step, if you want, in that direction. The key thing is, create self-contained objects like you always do. Now you can do your own kind of logic there, but there are obviously a lot of frameworks that already exist, and before you go reinvent the wheel, building your own MVC or MVVM architecture, look around. There are really good frameworks that are doing that pretty well. So again, the goal here is not for me to tell you which framework you should use, but at least I want you to be familiar with the landscape. And the way I look at it, there are really two types of frameworks out there. There are, on the left, what I call full stack frameworks. On the right, what I call custom stack frameworks. Build your own type of build your own type of stack if you want. A full stack framework like, for instance, Sencha or Dojo or jQuery Mobile, they cover DOM manipulation. They cover architecture, so the MVC type of stuff, and they also cover the UI, so they give you, style components. So everything, it's like one-stop shopping, which has pros and cons. Obviously, it's hard to, suppose you like Sencha, the way they do the architecture, but you don't like the look and feel of their components. It becomes a little more tricky to select only one piece of a full-stack framework. So the other option is to build your own stack. You say, hey, I don't like jQuery because it's too heavy for mobile application. I like Zepto, for instance. It's the same syntax, but it's a lot lighter weight. It doesn't care about IE6 compatibility. So I'm going to use that for DOM manipulation. I'm going to use Backbone, or I'm going to use Angular for providing the structure of my application. And then for the UI, I'm going to use Twitter Bootstrap or Foundation or Ratchet, which is what you have been seeing in my sample applications. It's kind of a nice prototyping CSS library that has really nice polished styles. I think it was built by some of the guys who initially built Twitter Bootstrap, but the focus is really on mobile application. Or I'm going to build my own CSS from scratch because we have very talented designers. So you really build your own stack. And depending on the type of application, if branding is really important for you, then you will probably want to go to the right. If you build a traditional inside the firewall, more enterprise-like application, the look and feel is not super important, then going to the left of this chart would actually be fine. And so the last piece of advice, the last principle that I want to share with you, and that's one of the most important ones, is to spend time understanding UI optimization and CSS optimization and things like that. Because again, we have seen that hybrid applications can be very, very, very close, almost indistinguishable from native applications in terms of user experience. But there is a little bit of work, a little bit of understanding to gain from the latest technologies out there. So a couple of things that I will highlight, and this is not a complete list. There are many other things that you could take a look at. Use hardware acceleration as much as you can. And so like a really good place to do hardware acceleration is like these sliding transitions with a couple of CSS declarations. You can actually use the GPU to accelerate these transitions and really have sliding transitions that are not jerky at all and behave really like native. I will show you a couple of examples. I'll go through the list and then I'll show you some code that implements that. So hardware acceleration is important. On some platforms, you want to be careful about using too much like gradient styles or box shadows and things like that. Again, testing is going to tell you if it's a problem on your platform, but these are things that can potentially slow down the rendering of your application. Of course, like always, you'll keep the DOM structure as simple as you can. And last but not least, I will say that's probably the #1 reason why applications are reported as laggy or not responsive. That is the click event delay that you find on iOS when running inside a web view. And so let me start with that one, and I will actually use an example to show you what happens here. I have an application that I'm just going to start here. That's going to work. Okay. All right. All right, here we go. Okay. So this is an application that doesn't look very nice right now. Need to polish it. But when you use the click event in your application, here's what happens. So I'm going to click that regular click box there. And you see that it took 368 milliseconds between the end of the touch end event on that div and then the time the click event was actually triggered. So that means that if you have a lot of click events throughout your application, every time the user is gonna touch that button or whatever, it's gonna take over 300 milliseconds before your code starts executing. Now 300 milliseconds doesn't sound much, but it feels bad. It feels like your application is not really responsive. So you see, every time I'm going to click, you see it's around 360 here, 360 milliseconds. And you can't see when I really tap it, but I can really feel it. I tap it, there is like a third of a second before I see the green showing up in that box here. And so that's kind of the default behavior because of the way events are handled. So the web view is gonna understand there is a touch start event, a touch end event, and then before triggering the click event, it's gonna say, okay, wait, I'm gonna wait 300 milliseconds to see if maybe it's not a double click that the user is doing. So after 300 milliseconds, say, okay, that's a click event that was intended, therefore I'm gonna trigger that click event. Now this is bad, and your application will really pay the price for that. You may not even notice, but your users are going to notice. So there is a solution for that. The cheap solution, again, is to say, okay, well, if I can't use click, so I'm going to go throughout my application, and I'm going to replace click, the click handler, by a touch end handler, because that one is triggered immediately. That sounds good, but it has two major drawbacks. The first one is that all of a sudden your application is not going to run inside a browser anymore, at least on most hardware, because you don't have support for touch. So now you have to add logic to handle click when touch is not supported. You see the problem there. But most importantly, relying on the touch end event may interfere with some other things, like for instance when you swipe your screen to do scrolling and things like that. So you will have to add a lot of logic to really understand that it was a click that was intended and use the touch end for that purpose. Now the good news is that a lot of smart people already wrote that logic to understand that it was really a click that was intended. And in fact, the application, the little JavaScript library that I'm using here is called FastClick, fastclick.js. You can Google it and you'll find it easily. And so let me click that fast button now, and you see the difference. It takes about 2-3 milliseconds before the end of a touch end event and a click that was actually generated by that library. And the nice thing about a library like that is that you don't have to go change the logic. You still listen for a click event, but they are going to trigger it automatically at the end of a touch end event for your convenience. So now this is a kind of down in the weeds, a small little detail, but believe me, throughout your application, remember that's all your user does is to touch and click. It's going to make a huge difference in terms of responsiveness. So that is one library. So let me actually show you that library to you. It's on GitHub. It was actually created by some guys from the Financial Times, but it's open source on GitHub. If you want to learn more about that, there is a really good description of the problem on developers.google.com fast buttons, and it really explains the problem, and it provides some ways to implement it. So if you want to do it yourself, it's pretty much implemented in FastClick or other libraries. Like for instance, Zepto.js has a tap event that you could use as well. So that would be another option. All right, so the last thing that I wanted to show you, and then we'll finish there, is like the transitions, and that's where I will show you the hardware acceleration piece. So this is, again, my employee directory in better shape. Okay, so you see that these transitions actually work pretty well. They work pretty well on the device as well as you saw before. So again, the UI, if you wonder which UI toolkit I used here, it's Ratchet. You can Google Ratchet CSS if you're looking for some quick components. They look great out of the box. But then what I did here for my page transitions. So I'm basically sliding these pages left and right. This is essentially the Translate 3D on the container is essentially what's going to give you the hardware acceleration. So if you can, if you want to learn more about that, you can download the source code. I'll point you to it in a second and take a closer look. But in a nutshell, that's really the way you're going to do it. And then to do the transition, you're going to apply a stage left, which is going to move the page out of the viewport to the left. And then for the opposite transition, you're going to apply a stage right here, which is going to move the page out of the viewport in the other direction. All right, so that's essentially what I wanted to tell you today. There is one more thing that I will quickly show you. This is my blog, and a lot of the code that I discussed today is based on this PhoneGap tutorial that you can find here. You can build that application from scratch. The application that I just walked you through, it's available on my blog from the home page in the menu bar. The code is on GitHub, so all these techniques, including the template loader and stuff like that, you can find right there. So that's the end of what I had for you. So what I'd like to do now is, I know we are just slightly over time, but I will take a few minutes here to, and I see that Alan helped me in the panel here. So if you still have questions, this is the time. All right, so I see here a question. What is a good library for page transition and page handling if you're not using jQuery Mobile? Yeah, good question. You will see if you download the code that it's actually a lot easier than you think. To get these nice transitions using CSS, it's just a few lines of CSS. So I would actually recommend try to do it by yourself. It's fairly easy for just UI. Instead of jQuery Mobile, I would say, take a look at Ratchet just for prototyping. And for page handling in general, I would recommend you take a look at some of these MVC frameworks. Like, for instance, Backbone has a pretty nice router API that's going to take care of managing pages and routing the user to the page that he or she was looking for. Where do I get touch event? I'm not sure exactly what you mean specifically, but on a device you'll get like the simple events like a touch start and a touch end, and then you'll have JavaScript frameworks that handle composite events based on that. They understand what a tap is versus a swipe and things like that. You can take a look at Zepto.js. It has some composite events. Hammer.js is another library you may want to take a look at. So there is a question here. I was told that the Facebook iPhone app was built using PhoneGap. Can anyone confirm that? In fact, the answer is no. It was a hybrid application. I don't think it was built with PhoneGap. They went to native, and that made some noise in the community, to be honest with you. We know, by experience that, the architecture could have been better. We have all been through the learning curve there, but they had their reason. They have, a lot of developers that they can put on a project. There was another, I think it's Sencha, that recently created, recreated the pure HTML version of it, implementing all these good design patterns, and I think they got, similar performance, if not better. So right now, the iPhone app is actually a native app. Let's see. Android does not support. Yeah, so depending on the platform, you are indeed going to have different types of performance. Some platform will support a Transform 3D and some platforms not. On Android, you want to be careful about other things that I mentioned before, like gradients and box shadow, especially when you do transitions. So you can take a look at that and test, and I think that's going to make a big difference. I have a single page application built using PHP when I build it and run it in WebKit background process. Yeah. So I'm not sure. So for the person who speaks about the PHP app, yeah, it's hard to diagnose like that. So I wouldn't venture into a full kind of assessment here, but what I would say is remember exactly what I showed you. You can still use PHP to get to your data. So, the preferred architecture is to build the UI at the client side so it works offline and things like that, and then still use your server-side scripting technology, whether it's PHP, JSP, ASP, Ruby on Rails, Node.js, to provide the data, typically in form of, JSON or JSON-P, but you build a UI the client side. You will see a huge difference in terms of responsiveness of your application. Can I use PhoneGap build if using Cordova? Really good question. Yes. So basically right now, for people who don't know, Cordova is essentially the open source version of PhoneGap. So at this point, it's the exact same code. If you download from Apache or from PhoneGap.com, this is the exact same library. Now, PhoneGap is giving you additional services, and PhoneGap Build is actually one of these services. Because it's the same thing, absolutely you can use Cordova with PhoneGap Build, but the way it works, and let me try to give you an example of that here. All right, so in the application that I just ran, you're gonna, when you prepare to build with PhoneGap Build, you're just gonna add this script here, PhoneGap.js. And the thing is, the PhoneGap.js doesn't have to live on your local machine. In fact, it shouldn't. What PhoneGap Build is going to do, it's going to inject the right version of PhoneGap.js, which again is the same as Cordova.js at build time. Because in fact, that JavaScript library is different for the different platforms. So PhoneGap Build is going to inject the right one at build time, and again, it's essentially the same thing as Cordova. So technically, the answer to your question is yes. Yeah. So for testing, so someone is asking which tool to use for testing. So there are different tools that you can use depending on the type of testing that you want to do. You can use Jasmine.js. You can use Benchmark.js for performance. So these are tools that you can take a look at, and that should be helpful. Some people speak about the flickering problem here. So for the most part, we've been able to avoid the flickering problem that was happening on specific platform. I know that jQuery Mobile was prone, to that problem. So if you download some of the recent frameworks, in fact, I have one of my colleagues, Andy Trice, who may be actually on the call, who has a little framework called App UI, and it does the transitions really nicely, avoiding the flickering as far as I've seen. So again, I can't really diagnose your specific problem without knowing more about your code, but we should be able to avoid that flickering problem today with the most recent libraries. Okay, someone says that App UI still has a 1 pixel jump at the end of the transition. Not sure on what platform that would be. Is this session going to be available later? Absolutely. So, Alan, I don't know if you can type in the URL. And I think that's going to be the time that we have for today. But what I will do, I will go through the list here and try to answer all these questions and post the transcript here on my blog. So apologies if I didn't have the time to answer your question live here, but I'll go back through the list. We have a long list of questions. Hopefully I answered most of them, but I will go through the list and post the answers on my blog. If you give me a day or two max, I will have a blog post with the answers. So I wanted to thank you for attending. There is a last survey here. I'll give you a minute to go through that. And unless Alan or Megan have something to add, I'd like to thank you for attending. Keep an eye on the calendar for other Tech Live sessions that we're going to have in the future. And I hope to see you there. Again, you can find me on Twitter and on my blog if you had any other question. So once again, thank you very much and have a very good rest of the day. Thank you. Bye-bye.
All right. Thank you so much, Christophe. And thank you, everybody, for all your interesting questions and conversations and for sticking around. We're going to be doing many more sessions, so you know, make sure you're following us on Twitter and come to the website and friend us on Facebook, and you'll get all the events, and please spread the word. So we'll leave that poll up for a little bit, and we'll be shutting this down shortly. We'll give it a couple of minutes for some final chat questions. But thank you all, and we'll see you all soon.